Hello, my dear students. Good afternoon. Today also we are discussing important questions from the chapter electricity. Okay. Already in last two classes we have discussed some important questions. In this class also we are continuing that. Okay. Be ready with your notebook and pen, and please note down the important questions and try to solve the answer. Okay. Please try to solve the answer because we are solving more sums in this chapter. So because of that reason you have to solve the questions. Okay. Yes, let us start with the first question. Yesterday I gave one homework. A hot plate of electric oven connected to 220-volt line has two resistance coils A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in three cases? So you have to find out the current I. You have to find out, right? Here I will take RA as 24 ohm and RB means R2 as 24 ohm resistance and P is equal to 220 volt. Okay. Now we have to find out the I in case of when these resistors are connected separately, when they are connected in series, when they are connected in parallel. These two resistors, when they are connected in these three manners, we have to find out the current flow. Okay, please note down the given data. After that, we are solving this question. Here, in first case, when these are connected in parallel, when they are connected in parallel, here, in the first case, when they are connected parallel. So you have to use the formula 1 by Rp is equal to 1 by R1 plus 1 by R2. So here you know what is 1 by R1, that is 24, plus 1 by R2 is 24, that is equal to 24 divided by 2, 2 ones are 2, 12. Rp is equal to 12 ohm, right? What is the total resistance when they are connected in the parallel, that is 12 ohm? We have to find out the I in case of the parallel connection. I is equal to V by R formula. So that is equal to V, you know the value 220 divided by 12. So here, what is the value of V? It is given 220 volt. Yes, 220 divided by 12. What is the value? 220 divided by 12. So that is 18.33 ampere. 18.33 ampere. Okay. So that is the value of I, current flow, when they are connected in parallel. Next thing, when they are connected in series, what is the value of current flow when they are connected in series? You know the formula, Rs is equal to R1 plus R2 formula. Here you know the value of R1, that is 24 ohm, plus R2 value, that is 24 ohm. Total resistance is equal to 48 ohm. Then you have to find out the current. I is equal to V by R formula. Here V is equal to 220 volt divided by R is equal to 48 ohm in case of the series connection. Then I is equal to 220 divided by 48. 220 divided by 48, that is equal to 4.58 ampere. What is the value of I when they are connected in series? That is 4.58 ampere. When they are connected separately, when they are connected separately, here which form, the R value is 24 ohm. because they are not connected in series or parallel, they are connected separately. That is that I will take the R value, that is 24 ohm. Then I is equal to V by R formula. V by R, you know the value of V, that is 220 volt divided by 24. So what is the value of I? 220, 220 divided by 24. So that is 9.16 ampere. Okay, so these are the three cases of connection of these resistors. So when they are parallel, when they are in series, or when they are connected separately. So we here the value of I is given like this. Okay, please note down this question. Please note down the answer. Next question. Show how you would connect three resistors, each of the resistance 6 ohm, so that combination has a resistance of 9 ohm and 4 ohm. Here, three resistors. So R1, that is equal to 6 ohm, R2, that is equal to 6 ohm, and R3, that is equal to 6 ohm. So this is the three resistors. So this combination of resistor, so that the total resistance should be 9 ohm and the 4 ohm. How you should connect these resistors? First, I will take when these are connected in parallel, when three resistors, both all three resistors connected in series. So in parallel, 1 by 6, directly I will apply 1 by 6 plus 1 by 6 plus 1 by 6, that is equal to 6 divided by 3. 3 ones are 3 twos are. What is the total resistance? That is 2 ohm, not 9 ohm, not 4 ohm. When these three resistors, when they are connected in parallel, the total resistance will be 2 ohm, not 9 ohm, or not, it's not a 4 ohm. Okay. So I will take Rs is equal to R1 plus R2 plus R3, that is 6 ohm plus 6 ohm plus 6 ohm, that is equal to 18 ohm. The total resistance will be 18 ohm. That is also not correct. So what we have to do now? Now I will connect the two resistors like this in parallel. Two resistors in parallel like this. Okay. Then one resistors in series. We'll connect this here. One resistor, 6 ohm resistors in series. Okay. So now, so just imagine this is a electric circuit where two resistors are connected in parallel and one is connected in series. Now you have to find out the 1 by Rp is equal to 1 by R1 plus 1 by R2. First, you have to find out the total resistance when they are connected in parallel. Here, 1 by Rp is equal to 1 by 6 plus 1 by 6. That is equal to 2 by 6. 2 3s are, that is equal to 3 ohm. Okay. So, the total resistance is 3 ohm. And another is connected in series. So you have to, what you have to do? When it is connected in series, Rs is equal to R1 plus R2. Here R1, that is 3 ohm. I will take these two resistors resistance plus 6 ohm. that is equal to total resistance R is equal to 9 ohm. So how we have to connect the resistors to get the 9 ohm total resistance 9 ohm in a circuit? Two 6 ohm resistors, they should connect it in a parallel manner, and one resistor that should be connected in a series, 6 ohm resistor in series. So like this we have to make the connection. Okay. Yes. Please note down the question. And one more thing, how we should get the 4 ohm resistance. Yes. Next term, 4 ohm resistance we have to get. Here R1 plus R2 plus R3, that is equal to 6 ohm. Here I will connect two resistors in series. Two resistors in series. Okay. Two resistors in series. So Rs is equal to R1 plus R2 formula. When two resistors are connected in series, that is 6 ohm plus 6 ohm, that is equal to 12 ohm. And one more is connected in parallel and another is connected parallel to these two resistors. Then 1 by Rp is equal to 1 by R1 plus 1 by R2 formula. Here the total resistance of the resistors connected in series, that is 12 ohm plus 1 by 6. Then 12 divided by 1 plus 2, that is 3 by 12. 3 ones are 3 fours are. So Rp is equal to total resistance is equal to 4 ohm. So how we should connect these resistors? When two resistors are connected in series and one resistor that is connected in parallel, so we can get the 4 ohm resistance. Okay, that is the correct answer. Please note down this. Next question. Yes, this is the answer. When two resistors here, when two resistors, 6 ohm resistors are connected in parallel and one resistor connected in series. Here, two resistors are connected in series and one is connected in parallel. So, we can get the 9 ohm and the 4 ohm resistance. Next question. Compare the power used in 2 ohm resistors in each of the following circuits. 6-volt battery in series with 1 ohm and 2 ohm resistors. 4-volt battery in parallel with the 12 ohm and the 2 ohm resistors. Here in case of first series connection, V is equal to 6 volt. Then R1 is equal to 1 ohm and R2 is equal to 2 ohm. Okay. And in case of the second one, V is equal to 4 volt and R1 is 12 ohm and R2 is 2 ohm. R2 is 2 ohm. Okay. So you have to compare the power used in 2 ohm resistors. So the power used in these two resistors, please note down the given data here, R1 and R2 and V. Here, which formula we can apply? P is equal to VI formula also we can apply. P is equal to V into I formula also we can apply. Or we can apply P is equal to V square by R. So this is the easy one. Here, first, in case of the series connection, series connection. Find out the total resistance. Rs is equal to R1 plus R2. What is the value of R1 and R2? Rs is equal to 1 ohm plus 2 ohm, that is equal to 3 ohm. The total resistance is equal to 3 ohm. Now apply the formula to find out the P. P is equal to V square by R. Here, what is V? That is 6 square. 6 square by R is 3 ohm. That is 36 by 3. 3 ones are 3 twos are. That is equal to 12 watt. 12 watt is the correct answer for the first one. Okay. Here, first you have to find out the total resistance, that is 3 ohm. Apply the P is equal to V square by R formula. V square, that is 6 volt already given, that is 6 square, that is the 36, and R means the total resistance, it is 3 ohm. Okay. Next, in case of the parallel connection, 1 by Rp is equal to 1 by R1 plus 1 by R2, right? Here, R1 is 12, 1 by 12 plus 1 by 2. So, 12 divided by 1 plus 6. 1 by Rp is equal to 7 by 12. Rp is equal to, that is 12 by 7 ohm. Okay. So, this is the total resistance. Now, we have to find out the P is equal to V square by R formula. That is equal to V square means 4 square. 4 square divided by 12 divided by 7. So just check it. The value of V is, that is 4 volt. Yes, 4 volt. That is 4 square means 16. Right. 4 square means 16 divided by 12 by 7. Please solve this. 16. So 7 into 7 divided by 12. 4 fours are 4. 3s are 28 by 3. 9 point something watt, right? 28 divided by 3 means 28 divided by 3, that is 9.33 watt. 9 point P is equal to 9.33 watt. So this is how to solve the question. Okay. Just apply the V square by R formula. V, you know the value 16, V square value 16, and 12 by 7. So this 7 will get multiply with the 16, then solve this. Okay. Then solve ಮಾಡಿದಾಗ 28 by 3 ಬರುತ್ತೆ. Then you will get the value 9.33 watt. So this is 12 watt. Please note down the answer. Yes, this is how to solve the same question. When they are connected in series, so total resistance, that is 3 ohm, and the power is equal to 12 watt. And here, where they are connected in parallel, you have to apply the formula, find out the resistance, that is 12 by 7, and the value of P will be 9.33 watt. Next question. Two lamps, one rated 100 watt and at 220 volt and other 60 watt at 220 volt are connected in parallel to an electric main supply. What current is drawn from the line of the voltage supply, that is 220 volt? Here, please read the question carefully. Two lamps, one rated. What is the power of the first one lamp? That is 100 watt. And what is the value of voltage? That is 220 volt. That I will take V1. Then another lamp that is having the power, that is 60 volt, 60 watt. And what is the voltage? That is 220 volt. Right. So this is the given data. What you have to find out, current is drawn from the line if the supply of voltage is 220. What is the current? So you have to find out I. What is the value of I? You have to find out. Please note down the given data and what you should know what you have to find out. Okay. Then just apply the formula. P is equal to power is given there and voltage is also given, V into I formula. P is equal to V into I formula. Okay. Here already P is given. Just a minute. So you have to find out the I. I is equal to P by V. Okay. So I is equal to, what is the value of P? Power, that is 100. I1 I will take. Okay. So in the first lamp, you have to find out the electric current in the first lamp. So the power is 100 watt. P1 by I1 is equal to P1 by V1 I will take. Then 220 volt voltage. So I will cancel the 0. Then 10 by 22. Okay. Or you can again you can take it as 100 divided by 220 also you can take. I1 is equal to like this and I2 is equal to P2 by V2. So that is equal to P2 value is 60 volt divided by 220. So I will cancel 0, 0. I2 is equal to, what is the value? 6 divided by 22 ampere. Now you have to find out the total current drawn from these two lamps. I is equal to I1 plus I2, right? Here I1 is 10 by 22 plus I2 is 6 by 22. That is equal to, try to solve the question. Here 22 divided by 10 plus 6, 16. I is equal to 16 divided by 22, that is 0.72 ampere. What is the total current? That is 0.72 ampere. Yes, like this you have to solve this question. Please note down the answer. Okay. So let us move to the next question. Yes, this is how to solve the same question. Here they have taken the 100 by 220 same 100 by 220 and 60 by 220, or you can cancel also. You can solve also, so that makes that easy. Okay. Next one. Which uses more energy? A 250-watt TV set in 1 hour or 1200-watt toaster in 10 minutes? Here, TV that uses, what is the power of the TV? Power of the TV, that is 250-watt TV. And what is the time? That is 60 minutes I will take. Okay, 60 minutes, that is 1 hour. Then what is the power of the toaster? Toaster, that is 1200-watt toaster. 1200-watt toaster. Then time, that is equal to, 10 minutes. Time is equal to 10 minutes. 10 minutes. I will convert the minutes into seconds. So this will be 600 seconds. For 1 minute, 60 seconds, 60 into 10. So 60 minutes means 60 into 60, that is 3600 seconds. Okay. Then find out the energy consumed, which consumes the more energy. So here TV, so that is having the power 250 watt and the time used, that is 3600 seconds, that is equal to 25 into 36. 25 6 0 1 5 9 0. Okay. 1 2 3 joules. And here 600 into 1200 watt. So that is equal to 7 to 1 2 3 4. Okay. So 7,20,000 joules. So here the TV uses more energy compared to the toaster. Okay. So it uses more energy. You can write 9 into 10 raised to 5 joules, or here also you can write 7.2 into 10 raised to 4 joules. So here it uses the more energy. TV, it uses more energy compared to the toaster. Next question. An electric heater of resistance 8 ohm draws 15 ampere from the service mains 2 hours. Calculate the rate at which heat is developed in heater. Okay. So here R is given. R is equal to 8 ohm. And what is I? The current, that is 15 ampere. Just a minute. R is equal to 8 ohm and I is equal to 15 ampere and time is equal to 2 hours. Calculate the rate at which heat is developed in the heater. So which formula you have to use? H you have to find out. Please use the formula H is equal to I square RT. H is equal to I square RT formula. Here I square means 15 into 15 and R is 8 and the time 2 hours, that is in seconds, 7,200 seconds. So that is equal to 1,800 into 7,200. Heat produced is this much. Then what is the rate at which heat is produced? P is equal to H by T formula. Okay, P is equal to H by T here. H is equal to 1800 into 7200. Then here divided by time, that is 7200 seconds. So I will cancel this. So at the rate at which it is produced, 1800 watt. Okay. So like this you have to find out the answer. Please try to solve this question. Next question. Why are the conductors of electric heating devices such as bread toasters and electric irons made of an alloy rather than a pure metal? Note down the question. Here, the resistivity of an alloy is generally higher than that of its constituent metals. So, when the resistivity is high, alloys do not oxidize or readily at high temperature. Because this reason, conductors of electric heating devices such as bread toasters and electric iron blocks made of alloy rather than a pure metal. When the resistance increases, the production also increases. So the alloys are used. Next question. An electric bulb is connected to a 220 volt generator. The current is 0.50 ampere. What is the power of the bulb? So this is very simple question where V is given. V is equal to 220 volt and I is equal to 0.50 ampere. So you have to find out power. What is the power of the bulb? Here you can use the formula P is equal to V into I formula. P is equal to, what is the value of V? That is 220 into 0.50. What is the value of P? 220 into 0.50. 220 into 0.50, that is 110 watt. Please note down this question. Next question. 100 joule of heat is produced each second in a 4 ohm resistance. Find the potential difference across the resistor. Here, 100 joule heat is produced. That is H is equal to 100 joule and produce each second in 4 ohm resistance. R is equal to 4 ohm, that is, okay. Find the potential difference across the resistors. V is equal to what you have to find out. Then what is the value? T is given, that is 1 second. Okay, for each second. Here, which formula you can use? H is equal to I square RT, or I is equal to square root of H by RT formula you can use. Okay. Here, we don't know the value of I. I is equal to square root of H means 100 divided by R, that is 4. 4 into 1, that is RT value is 1 second. Already 1 is given. 4 ones are 4 twos are 8. 4 5s are 20. I is equal to square root of 25. What is the value of square root of 25? Square root of 25, that is equal to, I is equal to 5 ampere. What is the value of current flow? That is 5 ampere. Then you have to find out the answer, that is the value of V, right? You can use the formula. Sorry. What is the value of I? That is 5 ampere. Already we know the value. Sorry, once again I will write. Please note down the given data. H is equal to I square RT. I is equal to square root of H by RT. I is equal to square root of 100 divided by 4. I is equal to 5 ampere. So, then V is equal to I into R formula, you know that. Then what is the potential difference? V we have to find out. V is what is the value of I? That is 5 ampere. And what is the value of R? That is 4 ohm. V is equal to 20 volt. What is the value of potential difference? That is 20 volt. Okay. First you have to note down the given data. That is the value of H is equal to 100 joules. So T is equal to 1 second and R is equal to 4 ohm. So V is equal to IR formula and find out the value of, first you have to find out the value of I is not known, then find out the value of V. Okay, so that is the correct answer. Next question. How can 3 resistor of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance 4 ohm and 1 ohm? Okay. So when R1 is 2 ohm, R2 is 3 ohm and R3 is 6 ohm. So we have to make the connection where the total resistance should be 4 ohm and 1 ohm. So I will connect them in parallel. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I will connect these 3 resistors in parallel. So 1 by 2 plus 1 by 3. Let us check this, 1 by 6. So here 6 divided by 3 plus 2 plus 1, that is equal to 6 by 6, that is equal to 1 ohm. The total resistance Rp is equal to 1 ohm. Okay. So when we connect these 3 resistors in parallel, we will get the answer 1 ohm. Right. So that will be the 1 ohm resistor. And now I will connect the 2 resistors in series. I will get 3 plus 2, 5, 6 plus 5, 11 ohm. So I will not connect them in series. Now I will connect two resistors in parallel and one resistors in series. Okay. Two resistors. I will clear this. Two resistors. These two resistors like this. 3 ohm and 6 ohm resistors in parallel and one resistor in series. Okay. First I will do the series parallel connection total resistance, that is 1 by 3 plus 1 by 6, that is equal to 6 by 2 plus 1, that is equal to 3 ones are 3 twos are. Rp is equal to 2 ohm. The total resistance of these two parallel connection, that is 2 ohm, and series connection, that is one more is 2 ohm resistance. Rs is equal to R1 plus R2. R1 plus R2. So 2 plus 2, that is equal to 4 ohm. The total resistance of these two resistors, that is 2 ohm, and one more resistor connected in series, that is also a 2 ohm. The total resistance is 4 ohm. So if you get the 4 ohm resistance in a circuit, means two resistors, that is 3 ohm and 6 ohm resistors are connected in parallel and one resistor 2 ohm resistor that is connected in series. So like this we have to solve the formula. We have to do the trial and error method for this question. Okay, so first we have to try the parallel connection and combination of the series and the parallel connection, then you will get the answer. Okay, so dear students, I will stop the class here and will continue in the next class. Thank you. If you have any doubts, please write down in the chat box. Yes, thank you dear students.